Everyone, welcome to section 3.4. In this section, we are going to be working with properties of logarithms. So we are going to be applying the product, quotient, and power properties of logarithms in this section. So let's begin by discussing the product property. Let b, x, and y be positive real numbers where b cannot equal 1. And let's say that we have this product property. It says the log base b of x and y converts into the sum of logs, log base b of x plus log base b of y. So if you have a product between an inside of a log, they can split, becoming an addition property. Now the quotient property, it begins with x and y in a single log, and it converts to the log base b of x minus the log base b of y. And then lastly, the power property says if you have a log base b of an x to the p power of an exponential, what happens to the exponent, it actually will come to the front of a log. So you'll have p log base b of x. So what we're going to be doing is that we are going to be using these properties. So let's look at question 1. We are going to use the product of logarithms to write it as a sum and simplify if possible. So notice I have log base 2, x, and y. The 2, the x, and the y are multiplying with each other. So then you can rewrite this as a log as a log of 2 plus, log of 2. Let me rewrite this. Log of 2, and it doesn't have a base. Do you see how the base is just, it's going to be the natural base of 10. Log base 2 plus log base of x with x plus log of y. So see how the 2 times x times y, they're all split apart. Log of 2 plus log of x plus log of y. Now for number 2, the 2, the 2, the x, and the y are multiplying with each other, but now see how you have a base. So you have the 2, the x, and the y, but now this one does have a base. So you'll have log base 2 of 2 plus log base 2 of x plus log base 2 of y. See how you're multiplying the 2, the x, and the y? Now, log base 2 is something that we learned in the past. So when we went over log properties and we had log of 2, log base 2 of 2 is actually equal to 1. So we saw that already when we had log base b of b was equal to 1. So then we can simplify log base 2 of 2 to be 1 plus log base 2 of x plus log base 2 of y. And that will be our solution. Okay, so simplifying log base 2 of 2 as 1. Now, the next one, the 3 and the a plus b, you have a product. So you have ln of 3 plus ln of a plus b. You do not split this one. You do not split the a plus the b. Only you split the products. So the product is between the 3 and the a plus b. Now, similarly, that was just using the product property and logarithms. Now let's use the quotient property. We want to use the quotient property, and then we want to simplify. So let's get started. I have a log base 7 of z over 19. So the property of the log says, remember that the property, it says the log base b of x over y will be log base b of x minus log base b of y. So that's what we're going to do here. Log base of 7 of z minus log base 7 of 49. But wait a second, log base b of 49, so here how do I change this to an exponential? I want to be able to simplify. So in reality, this is 7 to the what power gives me 49? And that power is 2. So all this becomes a 2. So we have log base 7 of z minus 2. So we had to simplify log base 7 of 49 as 7 to the what power gives you 49. That answer is 2. Same thing here. Look at question 5. For question number 5, I will have log base 7 of a minus log base 7 of 14. But be careful. If I want to simplify, can I simplify this value? And the answer is no, because there is no 7 to the what power gives you 14. So log base 7 of 14, you do not simplify further. That's it. So your final answer is exactly log base 7 of a minus log base 7 of 14. So be careful. So this is saying 7 to the what power will give me 14? 7 to the power of what? There doesn't exist anything. You don't simplify that. And last but not least, let's look at number 6. I have log base. See, remember, this one doesn't have a base, but I have log of 10, log of 100 minus log of x plus y. Now be careful, because if you don't see a natural base, the natural base of log, so the natural base of a log is actually 10. So in reality, this is log base 10 of 100 minus log base 10 of x plus y. Now again, log base 10 of 100 can simplify. 10 to the what power gives you 100? That's to the square power. So all this becomes a 2 minus log of x plus y. So if you don't see the base, it's because the base will be 10 automatically. Okay. So far, so good. Hopefully, so far we've done the product property of logarithms and the quotient property of logarithms. Let's go ahead and move on to the power properties of logarithms. Remember, what is that property? So that property says the following. Let me write it over here. If you have log base log of b to the p, it becomes p log of b. So then that means that the exponent will come to the front. So then here I will have ln of x to the fifth. Well, the fifth will come to the front as 5 ln of x. Same thing here. We have ln of e to the fifth. We'll have 5 ln of e. Now this is a special case because I can simplify. How do I know I can simplify? Well, ln has a natural base of e. So in reality, this is 5 ln of ee. Well, using the properties of ln of ee is equal to 1, I can simplify this as 5 times 1 to get 5. And 5 is my answer. Now, question number 9. See how we don't see an actual exponent, but we can convert it. So we have, recall the property of exponents. X to the, this is the square, this is the n, this is m, this is x to the m over n. If we have a root, recall the properties of exponentials. So what I'm going to do is I'm going to change it. I have log of x to the 2 over 3. Now that I rewrote it as an exponent, I'm able to bring it to the front as 2/3 log of x. So one of the things that you had to do prior is to remember to use the properties of exponents to change the square root or the root property as an exponent first. Okay. Now, what about if it's in reversed order? Now, what if it's in a quotient? Now we want to write the expression as a sum or difference. So instead of, now I'm going to have a match. So see how I'm going to combine. So this is now going to be the combinations of different properties, of all properties. So we're going to use the information that we just learned. So we're going to do all of the properties together, and then I'm going to play around and simplify what we're given. So the first thing we want to notice is that I have a division, right? I have a log base 3 of 5z minus log base 3 of w. Now I see another property, and that property is the multiplication. So I need to split those and do, okay, well, that's log base 3 of 5 plus log base 3 of z minus log base 3 of w. Okay. Now, similarly, I will have log base 7 of AC minus the log of 7 of 5D. Now I have two products, so I have log of 7, then I'm going to do A plus log of 7 of C minus, I'm going to put a bracket because the subtraction will go in the front of log base 7 of 5 plus log base 7 of D. See how I'm splitting the 5 and the D, the A and the C? But that has a subtraction in there, so I have to rewrite it as log base 7 of A plus log base 7 of C minus, if I distribute this negative, minus log base 7 of 5 minus log base 7, of D, where this becomes my final answer when I distribute that negative. Okay, so very slowly making sure that I understand where are the properties coming from and what am I going to use. Let's look at the next one. I have a product here between x squared and y. So I will begin by using the addition property ln of x squared plus ln of y. Now I identify that I have a square here, or the power property. That means that this has to come to the front, to ln of x plus ln of y. And that will become my solution. Everyone, welcome back to the continuation of section 3.2. This is where we left off working on number 13. So right now we are mixing and matching all of the properties of logarithms, or ln. And the first thing that we see is that we have a division. So if we have a division, that means we are going to do subtraction first. So we have an ln of the cube root of x squared, and then minus ln of w plus z. Now we want to rewrite this exponent as this root as an exponent. So we have an ln of x to the 2 over 3 minus ln of w plus z. Now notice on the w plus z, there's nothing else we can do. We cannot simplify, but we can do something of property here, and that's the properties of exponents. So the 2/3 will come to the front. I'll have ln of x minus ln of w plus z. And that will become my final answer. Now, looking at number 14, now we have the log base b of 2. So the first thing, I have to rewrite log base 2 of 4x over yz to the third, all raised to the 1/2 power. And that's because there is this big root in there. So this root that I'm going to highlight represents this 1/2 to the front. So that's the first thing I need to do and take care of. So I'm going to use the property of exponents, and I'm going to bring this 1/2 to the front, and then I'll say log of 2 of 4x over yz to the third. Then I'm going to use the properties of subtracting the logs because I have a division. So the 1/2 will stay up front. I'll have log base 2 of 4x minus log base 2 of yz to the third power. Now I have multiplication within those logs. So I have a 4x and a y to the y times z to the third that has to be expanded. So I have my 1/2. I will have log base 2 of 4 plus log base 2 of x minus log base 2 of y plus log base z of the cube. Now I'm going to simplify this log base 2 of 4, and this 3 will come to the front. So finally, log base 2 of 4 is 2 because 2 squared is 4. So this will simplify. I'm going to rewrite it over here. I will have 1/2 times 2 plus log base 2 of x minus log base 2 of y minus, because I'm distributing, 3 log of z. I'm going to go ahead and multiply everything out. So let me rewrite it. I had minus log base 2 of y minus 3 log base 2 of z. Then see how I'm going to have to multiply it out? So then I'm going to have 1 plus 1/2 log base 2 of x minus 1/2 log base 2 of y minus 3/2 log base 2 of z. And that is indeed my solution for number 14. So 14 is a little long, and so that's something that you can expect on one of the tests or assignments to do. Let's go ahead and do number 15, which is very similar to what we're going to do. We're going to split it apart. So we're going to first do log base 8 of 64x squared y minus log base 8 of 3zw cubed. Right? We split it apart. Now we emphasize on the product rule. So we have log base 8 of 64 plus log base 8 of x squared plus log base 8 of y. That's the first part. Minus, parenthesis, log base 8 of 3 plus log base 8 of z plus log base 8 of w to the third power. Now finally, I'm going to simplify log base 8 of 64, which we know is 2, plus, there's a property of powers, 2 log base 8 of x plus log base 8 of y. Now let's go ahead and distribute and then see how we're going to have this power rule. Minus log base 8 of 3 minus negative log base 8 of z minus 3 log base 8 of w. And that's exactly what we're going to finalize in this problem. Okay. Alrighty, so let's go ahead and now what if we want to write a logarithmic expression as a single log? Now we have it expanded out. We want to make sure that we condense it. So let's go ahead and do that. Now we notice that there's a subtraction between the logs. If we have a subtraction, that means division. So that means I have a log. On the numerator, I will have a 4x minus 3 over an x. So this arguments, this x and the 4x minus 3 determines the numerator and the denominator. Now, if I have a plus on number 17, I have a plus and then a 4. So remember, if I have a plus, that means a product. But I also have a 4 that's actually going to use the power rule. So I'm going to do that first. I use a power rule first. So I'm going to say this is log base 2 of z plus log base 2 of y to the fourth. Now I'm going to use the product. So it's going to be log base 2 of z times y to the fourth. I'm condensing the log or writing it as a single logarithm. All right, so now the next one I have a plus and then I have a minus. So if I have a plus, that means I'm going to do a product here. I'm going to do a product and a power because of the 3 on the inside, on the front. And then I'm going to have a subtraction. So here I'm going to use a division. So the product means I'm going to do ln of x cubed plus ln of x minus 2. So I'm going to use the product between these two as ln of x cubed times x minus 2. Okay. And then minus ln of 5. So that means that I'm going to use the division. So this is my numerator. And the 5 will be my denominator. So then I'll have ln of x cubed times x minus 2 all over 5. So as I'm going along, I'm explaining the steps. Alrighty, so number 19, it's kind of distributed out a little bit. So then this too applies to both logarithms. So I'm going to do 2 ln of x minus 2 ln of x squared. And then I'm going to do plus this 2/3 ln of z to the ninth minus ln of z. Remember this 2/3 and these are powers. So I will have ln, I'm going to rewrite it first. I will have ln of x squared minus ln of x to the fourth because square square is a fourth degree. So 2 times 2 is 4 plus ln of z, 9 times 2/3 minus ln of z. Now, I'm going to use the fact that I have an ln of x squared and then a plus. I'm going to combine them, ln of z. Well, I have 18 over 3, which is 6. And then I'm going to combine the minus ln of x to the fourth minus ln of z. So I'm going to rewrite it, the minuses together. So notice that I combined the minus ln of x squared and minus ln of z. So then I have a product between here. So it's going to be ln of x squared times z to the sixth here minus ln of, well, if I factor out a negative, if I factor it out, I will have x to the fourth z. So what I did is I factor the negative out. If I factor the negative, this is negative ln of x to the fourth plus ln of z. But then if I have a plus, this becomes a product. So see how I have x to the fourth z. Now I have a subtraction in between. That means the division. So it's going to be ln of x squared z to the sixth all over x to the fourth z. And finally, I'm going to simplify the inside of the log ln of, I have an x squared on the top and x fourth to the bottom. I have an x to the square on the bottom. I have 6 z's and 1 z on the bottom. That makes a z to the fifth. And this becomes my final solution. So what I had to do is I had to reorder, use and factor out a negative to use the product rule here, and then use the division because I have subtraction between ln's, and then finalize by simplifying the inside of a argument. Alrighty, let's look at number 20. So very similar, I have a negative 2. I have a negative 2 that I have to take care of. And I'm going to be able to rewrite it. And then I have log base 5, log base 5, and log base 5. So I'm going to rewrite this as log base 5 of x. Log base 5 of x plus log base 5 of x minus 2 log base 5 of x plus 5. So I'm going to bring this 2 to the front. So it's going to be, to the back, log base 5 of x plus log base 5 of, let me rewrite this. I had log base 5 of x squared minus 25. That's this one. And then minus 2 log base 5 of x plus 5. So add log base 5 of x squared minus 25. And then minus, I'm going to bring the 2 because it's a power as log base 5 of x plus 5 quantity squared. Now, this is a addition between logs or ln's. I'm going to unite them. So it's going to be log base 5 of x times x squared minus 25 minus log base 5 of x plus 5 squared. Now I have subtraction between a log. That means division. So it's going to be log base 5 of x times. Remember that x squared minus 25 is x plus 5, x minus 5. It's a difference of squares. So I'm going to apply that. All over x plus 5 squared. That means 2 of those, x plus 5 times x plus 5. And finally, I'm going to simplify an x plus 5 from the top, from the bottom. I should be left with log base 5 of x times x minus 5 all over x plus 5. And I'm able to do that because I'm using properties of difference of squares. So log base 5 of x times x minus 5 over x plus 5. Alrighty, for the next few that we have left, we are going to be approximating the value of log base b of 21 using log properties. So we are going to use log properties. Well, first, I know log base b of 3 and log base b of 7, and look at 21. So log base b of 3 times 7. So because I have a multiple, that means I can add log base b of 3 plus log base b of 7. But I know log base b of 3, it's 0.6826 plus log base b of 7 is 1.2091. So right now I'm using what I'm given. So let's go ahead and add this. We're going to be approximating it. So approximately 1.8917. Okay, now let's look at log base b of 9. Well, what can we do is we can rewrite this as log base b of 3 squared. So we rewrite 9 as 3 squared. So we're going to use the power rule and bring the 2, and we have log base b of 3. But we know log base b of 3 is estimated. So it's going to be approximately 2 times 0.6826. Go ahead and punch this on your calculator. What do we get here? So 1.3652 approximately. Again, just using log properties. And then here, well, then we are having a division between two logs. That means I'm going to use log properties and expand it to be log base b of 7 minus log base b of 2. But we know the approximation 1.2091 minus log base b of 2 is 0.4307. And let's punch this on our calculator. What do we get? So I claim you should get 0.7784. Let me rewrite that, 0.7884. Okay. And that is an approximation. Alrighty. So then let's go into the last two questions, which is called applying the change of base formula. Let A and B be positive real numbers such that A is not equal to 1, B is not equal to 1. So how do we use the change of base? So normally it's just going to be log of the numerator of the x divided by log of b, or log of x over log of b, or ln of x or over ln of b. So if we use the change of base formula, we have log of the big number, which is 15, over log of 7. Log of 15 over log of 7. Here we want to use our calculator, so please go ahead and open it up. You can use Calculate 84 or our free calculator. And you want to round to 4 decimal places. I'll give you a few seconds to do that. And that's approximately 1.3917. Similarly, if I have log of 0.3 over log of 5, or ln of 0.3 over ln of 5, right? Because there's two options. I usually stick with the log, but let's try plugging the ln. Let's use our calculator, and that's roughly negative 0.7481. And with that, we finish section 3.4. Thank you so much, and I'll see you guys next time. Bye-bye.